Good morning, online learners. In class the last couple of weeks, I kind of get the sense that you aren't able to follow along with us while we're doing things in class because of the way the cameras are set up, etc. So I'm going to try to make some videos to front load instruction to you that you can watch instead of having to sit through our lectures in class. So hopefully you can get this a little bit clearer. So we did this yesterday in class, everybody. You may be able to follow along, you may have not been able to follow along depending on how your internet was. So hopefully you can at least watch this video to get a little bit of understanding of how our jump starter is going to work for this week with ideas like latitude, longitude, parallels, North Pole, South Pole, degrees, all those different things that we did yesterday and we'll talk about this week. So behind me you will see we have my beautiful drawing of a map of the world. Now, where do we get a flat map of the world from? Because, as you hopefully know from science class, the world is a sphere. Well, every day the world turns around like this on its axis, and it rotates, and we get sunshine for half the day, and we get darkness and night for the other half of the day. When we're trying to map out the world, we have to take this globe, and we have to open it up by imagine like a cut along the globe, and then stretching it out to make a flat map of the world. And so that's what we've done here on my lovely art on the board behind me. We have a now flat map of our spherical globe. What we're going to learn today is how people have identified location and with precision can tell exactly where they are in the world, everywhere they are. This is what your phone uses this same system to help your parents drive you different places when they plug it in their GPS. So let's learn how all that stuff works. Now, as you can see here, this is North America. We live right about there. So that is us. And on the globe, most of you are familiar with the equator, this big fat blue line that runs all the way around the world and divides the world into two halves. So let's put our equator in. So we're going to call this the equator. Now the equator is an imaginary line. If you go to Africa or South America, you're not going to see a physical blue line on the ground. It's imaginary. But it helps us make sense of the world. And we use this as our 0 point on like a number line. Okay, so we give the equator as a rating of 0. Above the equator, we consider that to be north. Below the equator is south. And a couple interesting facts here. In North America, we think of going south as getting warmer in climate and that's because we're approaching the equator. As you approach the equator in the northern hemisphere, it gets warmer, right? If you go to Mexico, it has a warmer climate than we have in Colorado. The opposite is true in the southern hemisphere. South America is super cold, so the further south you go below the equator, the colder you get. So you get to penguin territory. Now, that brings us to the next idea of the poles. So at the very top of the Earth, we have the North Pole. And at the very bottom, we have the South Pole. In math, you may be familiar with the idea of a right angle. A right angle is where you have something that is 90 degrees or perfectly perpendicular with two lines. So if you were to consider this in math, the sign, that means right angle. And so we consider this to be 90 degrees north, because we are now north of the equator, and this is 90 degrees south, because we are south of the equator. And we're going to use this little symbol for degrees to measure the latitude and longitude of the Earth. It's the same symbol that we use to measure temperature, so hopefully you're familiar with that little 0 sign means degrees. So in this case we have the equator, which runs this way, and that helps us reference north and south. And the line that runs this way we're going to call the prime meridian. That's an M. The prime meridian runs from the North Pole all the way to the South Pole. Again, it's an imaginary line. You wouldn't actually see it if you were to cross it. And to this side of the prime meridian is going to be east, and on this side is going to be west. So these are like our coordinate plane. Now we have something like a grid like in math, and so we can now start to reference points off of these 0 lines. So let's put in the rest of the lines in the map that we need. We'll start with our north and south lines. These lines are going to be called parallels or lines of latitude. They're called parallels because these lines will never touch. They will cut across the globe just like this. I'm going to use red for my parallels. So let's put one in here. Our next one will be here. We'll put one in here. Put one in there. We'll put one more there. And now we gotta give them some terms. So let's give them a degree number. So we're going to go up. This will be 15 degrees north, 30 degrees north. As you can see, I'm just going up by 15 each time I go up. In between here would be like 16, 17, 18, 19, etc., all up to 30, and then you hit the next big one. But geographers use every 15 degrees as a marker. Again, we're going north until we finally get to 90 up there. And we can do the same thing going below when we go south. So let's put in our, you can do again 15, do 30, 45, 60, 75, and then we hit 90. So we're going away from it, the equator, so we're going south, so 15 degrees south, 30 degrees south, 45 degrees south, 60 degrees south, 75 degrees south, and then we hit 90 degrees south. So here we have like lines that give us position north and south. However, we're not ready yet to find our exact point in the world because 30 degrees north could be anywhere in the United States, the Atlantic Ocean, Europe, Asia, or the Pacific Ocean. So we don't know exactly where we are because we don't have any east and west positions yet. So we can do the exact same thing, and instead of having on this side, these lines are all called parallels, right? Or lines of latitude. And we can add lines going this way to give us the cross coordinate. So we can also do things like 15 degrees east. And then we can add in 30 east. Maybe 45, 60, 75, 90. So let me fill those in. And these are all going to touch at the north and the south poles. Okay, so now I've got my other grid, and now I can start to find out locations. Like right here, this exact point would be 30 degrees north and 30 degrees east. So I would write that point as 30 north, 30 east. And that would be the exact location of that point on a map. And the same thing works for the west, right? We would have 15 west, 30 west, 45 west, 60 west, 75 west, 90 west. Meridian, these lines are called meridians, or lines of longitude. And they are not parallel, right? These lines all touch the North Pole and the South Pole because the Earth is a globe. If the Earth was flat, these lines would also be parallel, but the Earth is not flat. The Earth is a sphere. So we have to show that it's a sphere. And so, but to do that, we have the non-parallel meridians that touch, and then we have the parallels this way. So there's my bell. Also, hopefully this gives you a little bit more of a background for the jump starter this week. Hopefully in the future I'll make more videos for you that'll be a little more informative than our in-class discussions, and you can have a little more freedom on your own end. Thank you. See you guys in class today. Have a great one.